Okay, so here are just a few problems that a student of mine had given me that have to do with logarithm type stuff. So let's look at this one. I'm going to say let's get the bases to match first. And that would be a matter of recognizing that that could be rewritten as this. And that's really just this. And once the bases match, you can then sort of ignore the bases themselves and recognize that the exponents really just equal each other. So that should equal that. And therefore, 2 minus x equals -3. We'll leave the negative x on the left, and -3 minus 2 is -5, so x equals 5. If the teacher wants you to check your work, you could always do 5 raised to the 2 minus 5, um, and kind of realize that that's 5 to the -3. And that is 1 over 5 to the +3. And that is indeed 1 over 125. All right, so that's how you could do that. Um, let's see. With this one, there might be a temptation to get the bases to match, and you should always ask yourself, can I get the bases to match? But the problem is there's no way of representing 137 as 5 to the something. All right, unfortunately. And one way I know that, by the way, is because 5 to the anything, okay, 5 to the anything is going to result in a 5 in the units digit. Okay, so maybe it's some number that's a 3-digit number, but I know that the units digit would be 5. So this units digit is 7, and that's a problem. So uh, I know for sure that this 137 cannot be represented as 5 to some exponent. So we are going to have to think about this one a little bit differently. And one way to do it is you could realize that Uh, ultimately, we're trying to solve for x, but x is kind of stranded up here in exponent land. So we have to find a way to bring it down to the bottom floor, or to the ground floor, we should say. And one way of doing that is by hitting both sides with a log, and not just any log, but a log with a base of 5. And the student whose worksheet I got these problems from hopefully understands that there is that sort of diagonal relationship between the bases here that we purposefully created just now. So that because of this diagonal relationship, hopefully my student remembers that you can just drop this exponent down to the bottom floor. And then you have this on the other side. Now, again, the goal is to solve for x, so hopefully we're all recognizing that we can just add 3 to both sides, and the next thing you know, you have x equals log base 5, and we have that plus 3. Now, this is something you could plug into a calculator, meticulously making sure that you have a base of 5 under this log. You have to know how to do that in your calculator. But I will say there's a good chance the teacher would actually accept this as the answer, because if you were to plug it into your calculator, you would get some decimal that you'd have to round. And in that, you would be losing accuracy, whereas this is perfectly accurate. So I would say that's the answer to that one. And the final problem we should look at is this one here. Now, there is that principle that says that log of x minus log of y, well, that could be condensed into log of x over y. So that's a principle. Well, we kind of have that here. When we look at this red principle, let's note really quickly that the bases do need to be the same. I wrote a little b here, I wrote a little b. Well, when you have the ln, that's really a logarithm with a base of e. Sometimes just kind of my own thing, I like to just put the e there just to remind myself that there really is, you know, a little tiny e underneath the logarithm. So the bases match, therefore we can use this principle, and therefore we can consolidate this to say that it's ln of the first thing over the second thing. And the purpose of doing that is to recognize that we have a single logarithm here, and it's equal to a single logarithm here, or I should call this a natural log if I'm going to be specific. We have a single natural log of something here and a natural log of something here. So doesn't it make sense that the value that's being subjected to the log, okay, or logified, I'll just make up that word, the value that's being logified here, it has to be the same value that's being logified over here. So therefore, we can ignore the logs and just be like, oh, okay, well, this thing must equal that thing. But then, of course, you have to go through the process of algebra to solve for x. Hopefully you could recognize that it would be nice to get rid of that annoying denominator that's down there. And the way to do it is by multiplying both sides by that denominator. And we would therefore be left with that on the left, and then you would have this on the right. Hopefully we're all seeing you could most definitely distribute that. And that would become x plus 4, x squared plus x. And we could subtract x from both sides, certainly. And as a result of that, we would have these cancel. We would be left with 4 equals x squared. And hopefully we're seeing that with that, you could take the square root of both sides. Now, hopefully my student recognizes anytime you take the square root of both sides, you have to go plus minus, okay? So you're taking the square root of x squared, which means you have to go plus minus on the other side. And on the right side, I mean, well, that's easy. That's just x. But on the other side, it's going to be plus minus the square root of 4, which is 2. So those are your answers in that case. And checking your answers, let's just double check because we do have a negative answer. We have a positive 2 and a negative 2. So let's check the positive answer by plugging in positive 2. We would have an ln 2 plus 4 minus ln 2 plus 1. And does that equal ln 2? Well, let's see. ln 6 minus ln 3 equals ln 2. Applying this principle would be ln of 6 over 3 equals ln 2. And that is ln of 2 equals ln of 2. So that is good. Now let's put to the test this one, negative 2, by plugging it in. So we have ln negative 2 plus 4 plus, or minus rather, ln negative 2 plus 1. And setting that equal to ln of negative 2. So we already have a problem here because you're just simply not allowed to take the logarithm of a negative number. So we can therefore conclude that -2 won't work. And therefore we can obnoxiously cross it out. And the only answer that works is +2. Hopefully that makes sense.